Okay, let's look at questions 20 and 21. So this is from chapter 6 review. I didn't choose all the problems from this section, just a couple that are relevant to what we've learned. Machine fastens plastic screw-on caps on the containers of motor oil. If the machine applies more torque than the cap can withstand, the cap will break. Both the torque applied and the strength of the caps vary. The cap and machine torque T follows a normal distribution with mean 7 inch-pounds and standard deviation 0.9 inch-pound. The cap strength C, the torque that would break the cap, follows a normal distribution with mean 10 inch-pounds and standard deviation 1.2 inch-pounds. So question 20, find the probability that a randomly selected cap has a strength greater than 11 inch-pounds. So the cap strength is what we're talking about. So the cap strength, the torque that would break the cap is has a mean of 10 inch-pounds and a standard deviation of 1.2 inch-pounds. All right, here's what a drawing of that would look like. This is actually a normal curve. This is all going back to chapter 2. We're given the mean and the standard deviation. I know that we have two random variables here. We have torque and cap strength, but this is actually talking about cap strength. So it has a strength greater than 11 inch-pounds. So we do have to use the second one here. So we have our mean of 10 and our standard deviation of 1.2. And let's recall how to put that in normal CDF. To do that, since we want to go greater than 11, we go second vars, normal CDF. Our lower bound would be 11. Our upper bound, it goes on forever, so it's infinity. So remember, we do 1, and then second comma E 99. Our mean is 10, and our standard deviation is 1.2. And that's going to be about 0.2023. So for work, we would say normal CDF. Our lower is 11. Upper is infinity, it goes on forever. Mean 10, standard deviation 1.2. We put those inputs in and we say it's going to be about 0.2023. So the interpretation of that is we would say the probability that a randomly selected cap has a strength greater than 11 inch-pounds is 0.2023. That a randomly selected cap has a strength greater than 11 inch-pounds is 0.2023 or 20.23%. So input that value there, 0.2023. So now let's interpret number 21. Okay, y'all got that? Number 21. Let the random variable D equal C minus T. So cap strength minus the torque. Find the mean and standard deviation. So this is a combined random variable. So if you look at the mean of the cap strength, so the mean of the combined, the random variable D, is going to be the mean of the cap strength. So mean of the cap strength minus the mean of the torque. So that's going to be 10 minus 7. And those are just right from the description here, right? We got a T was 7, C was a mean of 10. So that's going to be 3. So that's going to be 3 inch-pounds. Standard deviation. Now, when we're doing of subtraction for random variables, we don't subtract standard deviations. We add. Never subtract those. It's still going to increase the spread. So it's still going to be, even though the random variable is c minus t, it's still going to be the variances squared, and then we would square root those. So the standard deviation squared, then we'd square root that to get the standard deviation. So we have 0.9 squared plus 1.2 squared. That's your variance. So let's square those and add them together. And you can see that's 2.25. So the standard deviation of D is the square root of 2.25. Check that out in your calculator. It should be 1.5 inch-pounds. So never subtract standard deviations. Always combine, even if it's minus in the combination of the random variables. So I'll leave that open there. And that's it.